Okay, we are now up to notes 4. It's actually notes 4, and it's called the y-intercept and the slope-intercept form. This is the type of equation that we are heading into learning, the slope-intercept form of an equation, okay? All right, first off, you need to find what it means by, finding the y-intercept of a line. Well, intercept means to intercept a pass. It's to cross in front of, intercept the traffic, whatever. You're catching it, you're going through. It is where, the y-intercept is where a line crosses the y-axis. Get that into your head. Y-intercept is where the line that's going, you'll be graphing or you'll be reading about is crossing the y-axis. Okay? In 7th grade math, we did the COP, and this is why I started out my lessons with you guys understanding COP again. Remember COP. The y-intercept was 0. Okay? This is x, this is y. It always, the COP was constant of proportionality. It meant something increased at a constant rate, and if it wasn't increasing or didn't start, it started at 0. Let's take a look at this title here. Euclid's car wash charges. So if I look at this and I go, all right, time in the car wash at 0 minutes, somehow they're charging me $4. That's the y-intercept. They're not charging me 0. For me to pull into the driveway to go into Euclid's car wash, they're going to charge me $4. And then how long it stays there, it increases at some particular rate. So the y-intercept, now moving on into 8th grade graphing, is where the lines now are coming across the y-axis somewhere different than 0. Okay? In this particular equation, this was y equals the m times the x, where m was the slope okay? The m is their slope or your unit rate. And that's how this, in particular in 7th grade, increased. But over here, we are going to have definitely a rate of change. Clearly the line is increasing, it's going up. So like at 24 minutes, I'm getting charged $12. At 18 minutes, I'm getting charged probably $10, excuse me, 10. And so on. You could determine what your charge would be. But it started at $4. The form of the equation here is called the slope-intercept form. It will be y equals mx plus the b. And the b is your y-intercept. Now, in 7th grade, if I wrote down plus b here, it would be plus 0. Why would you write plus 0? You wouldn't. That's why we just use y equals mx. Now we're moving along now where we're going to have y equals mx plus b. So in this case, this equation would be y equals mx plus 4. Because this particular problem, it starts at $4 and then the increasing rate goes up based on the number of minutes, and minutes being the x. Okay? Stick with me, you will get this. All right? Very simple. We're going to only pick out y-intercepts now. We're not worrying about doing slope. In this particular graph, the y-intercept, okay? And for some crazy reason, they use the letter B for finding the y-intercept. We're going to put the letter B up on top of your notes here. Put the letter B there. That's the y-intercept. Where, okay, put in my words, where the line crosses the y-axis. It's often called the initial value. So the initial value at the car wash was $4, and then the price went up. Let's look at this one. Where is my B? My B in this picture is at positive 6. Okay? The B in this graph, where's my y-intercept? Right there. The B in this graph is positive 3. Okay? So we have two letters to kind of remember here. B represents the y-intercept, all right? And the m, which we'll do eventually, so we're going to get into this, y equals mx plus b. This will be committed into your brain through 8th grade, through 9th grade, through whatever. Very important. This is a linear equation, or at least one of them, of a linear equation. Okay? The B represents the y-intercept, and the M represents the slope, or the rate of change. And you will get a ton of this shortly. Everybody good? Everybody wrote all that down? Okay, let's turn the page. Okay, determine the y-intercept of a table, from a table. All right, this is interesting. Y-intercept from a table. Well, if you noticed on the page before, the page before, let's name this point right here. The point right here, okay? The point right here, if I identified it in a coordinate, is 0, 6. X is 0, the y was 6. Let's go up to the top. How would I name that point right there on the graph? Right there on the y-axis. It is 0, 4. The x was 0 and it was 4. Okay? Same with this one. The point right here, okay? Name that point is 0, 3. So, you see something that has in common? In order to be the y-intercept, the x value is 0. So let's turn again and look at our table. We have a table of values. So this is one coordinate, this is another, this is another, this is another. So this could all graph out to be a line, believe it or not. And the y-intercept is where the x value is 0. X value is 0 right there. So where is this line crossing the y-axis? At 0, -1. Got it? Okay. Oh, not so easy here. But could we figure out where 0 point would be? Notice this, the x is increasing by 1. So let's go backwards. We can go backwards and pretend we have one more set box. So this would be 0, wouldn't it? X is 0. Well, now I got to figure out the bottom, the y. Y, notice, I'm going to count it this way. 2, 2.5, 3, 3.5, 4, 4.5. What do you think that is? 5. Because the bottom was going this way by 0.5 to get there. So use some common sense and you could figure out the y-intercept here is 0, 5. Just take the chart and work it the other way. Okay? So remember, look for the x equaling 0, then that's the y-intercept. Okay? Take a look at this one. Do we have the x value of 0? Bingo, right there. So if x is 0, y is 4. So this point is 0, 4. Okay? We're good? Let's try this one. The squeaky clean car wash. Remember, the top is always your x, the bottom is always your y. How is this increasing? 5, 10, 15, 20, 25. Clearly, it's increasing by 5. For every 5 minutes going by, something, it's changing. And it's increasing here, I think we did this one before, 8 to 13, 13 to 18, 18 to 23, and so on. This also is going up by 5, right? By 5, by 5. by 5. So let's back down. At 0, well, if it was going up by 5, I got to go backwards by 5. Take 5 away from the 8, and what do we get? Right? If I go backwards, this is 28 minus 5 made 23. 23 minus 5 made 18. 18 minus 5 made 13. 13 minus 5 made 8. 8 minus 5 makes what? 3. So Squeaky Clean Car Wash charges you $3 just to show up. So it's Y-intercept is 0, 3. Starting at $3 and then going up from there. Okay? Try this one. No story here. We could make up one, but let's just think. We got 5, 10, 15, 20. So it's increasing by 5. So if I got to go back 5, I get to 0, comma, 20, 30, 40, 50, what do you think? 60. There's your Y-intercept is at 0, 60. All right? So again, look for the 0. Look for when x is 0. That's the Y-intercept. And if you can determine that by, going backwards on the table or forward, whatever it takes, look for the pattern to get to x being 0. All right? Next page is simple, simple, simple. Okay. Here's my y equals mx plus b. M stands for the slope, and b stands for the y-intercept. Guys, nice big letters. I'm going to write here y equals mx plus b. This is your slope. Whatever number is in front of the x, whatever number it is, that's the slope. Okay? And your b, the single number, the constant number floating out here all by itself, is going to be your y-intercept. Okay? So, how do I read these equations? In this equation, the number in front of the x, which represents the m, is a 4. The slope is 4. Positive 4 or just 4. Same thing. And the b is simply 7. Okay, you know what? I'm going to put the positives on here just so you emphasizes positive. In this one, y equals 3x minus 8. The slope, something is increasing at a rate of 3 to 1 or 3. But it started at negative 8, the y-intercept. Careful, careful. These two need to switch places, technically. This should be, and if you can do it in your head, great. If not, the negative sign belongs to the 7. So it's negative 7x. 6 is positive, plus 6. Notice I just switched their positions. Didn't change their signs or anything. We're not solving equations here. This is just rearranged it so that it's in the form of y equals mx plus b. But either way, the number in front of the x, the number in front of the x is your slope. In this case, it is a negative 7, and the y-intercept is 6. Okay? Next one. This one, y equals 10x, is a COP one, constant of proportionality. Okay? Because it has 10 as constant rate of change, so the slope is 10, or positive 10. What's the b? Or the y-intercept is at 0. Okay? On this one, y equals 12. If you were to graph this, you wanted to find every place that the y value is a 12. Every place that the y value is a 12. So this is x, this is y. Every place that y value is 12 is going to be way up here. So the line is going flat on 12. This would be every dot along here would have the y value of 12. So it's a flat line. So since it's a flat line, we know the slope is 0, and the y-intercept is right at 12. Or if you think of the point would be at 0, 12. Okay? All of these would be, this one would be 0, 0. This one would be at 0, 6. This one is at 0, negative 8. And this one is at 0, 7. Remember, the x value has to be 0. Okay? Given the slope 2/9 and the y-intercept is 3, let's write the equation. So the m is 2/9, and fractions are okay. It's rise and the run. So we're rising 2 units, but we're running 9 across. And the y-intercept, the b, the letter b, is a positive 3. I am simply filling in the m and b. Y equals 2/9 x. You have to have y and x in here. Plus 3. I'm just replacing the m and the b from my formula. Y equals mx plus b. These are the two things. You keep the y and the x where they are. Okay? Given the slope of 0 and the y-intercept of 1. Well, we said a slope of 0 had an equation that looked like this. And it crossed at 12. So this one would be y, whoops, my pencil's going, y equals, where is it crossing? Y equals 1. There is no slope. Slope is 0. So this is a flat line. Next one. Your m is negative 1, and your b is negative 6. Y equals negative 1x, okay, negative 1x, or just negative x. What's my b? Plus a negative 6. I'm just going to put negative 6. Okay? I'm going to try the next one. Y equals, my m is negative 2/3 x, and my b is plus 5. Okay? All right? Same thing. Crosses at 0, 2. Your b is 2. Y equals, my m, negative 4x. Where is it crossing? At positive 2. Next. Can be decimals. Y equals 0.4x, and that's a positive 0.6. That's your b. So, in summary, we are filling in this form of this special equation. It's called the slope-intercept form. Y equals, this is your m. M will be a number of some sort, positive or negative. Mx, always put the x. Mx plus or minus, it could be a minus, plus or minus the letter b. And the b is what you're going to fill in based on where the line is crossing the y-axis. This will be committed to memory. Y equals mx plus b. M is called the slope or rate of change, and the b is the y-intercept, where it crosses the y-axis. Got to commit these terms and words to your brain. Okay, the next page is actually homework. Oops, sorry. That you are to try these. Maybe I'll do this first one with you, and then the rest you're going to do on your own. Graph the following situation. Okay, so let's read it. Read it first, get an idea what's going on, okay? And then we'll try to get it to the graph. A swimmer climbs a ladder for 2 seconds to a water slide that is 5 feet high. So the height is up at 5. She sits for 2 seconds at the top of the slide, and then she slides 8 feet down the slide into the water. Well, she only went up 5 feet, but then slides down 8. Okay, so she's going below, like the water, for 2 seconds. So this is all in little intervals of 2 seconds. She stayed steady at the same position underwater for, okay, so now she's underwater for another 2 seconds before rising to the surface of the water in 1 second. She remained in the pool for 1 more second. Okay, so here we go. Got this picture in our head, what's going on? So let's kind of do the story or the drawing on this graph. First, I'll study the graph. The time part is your x-axis in seconds. Your y-axis is the height. The highest she was, or where she started, okay, the height she gets to, the swimmer climbs a ladder for 2 seconds. So the first 2 seconds, from 0, from the beginning, first 2 seconds, she gets to the height of 5 feet. So in 2 seconds, she was up at 5. So let's draw a line. Kind of like, okay, this is what she did. Got to the height of 5. We all there? She sits for 2 seconds at the top of the slide. So I have to pass another 2 seconds go by, but she didn't go any higher, she didn't go any higher, she didn't go lower. So flat on the top for 2 seconds. Right? She then slides down the slide into the water in 2 seconds. So from here, another 2 seconds pass, which is 2 boxes, but she went down 8 feet. Well, we know to here is 5 feet. So I have to go an additional 3 feet down to get to 8. 8. So getting over now from 2 more seconds, which gets me to 6 seconds, I'm down to below 3 feet below the 0 because this was 5 and I have to go 1, 2, 3 more. But it was an additional 2 seconds. So I'm going to draw kind of a steep line all the way down to there. Okay? Now she's underwater. Now where is she? 8 feet down, slides into the water for 2 seconds. She stayed steady at the same position underwater for another 2 seconds. So she likes 2 seconds. So she stays here for 2 seconds before rising to the surface of the water in 1 second. So only one width, she rises to the surface of the water in 1 second, where she remained in the pool for 1 more second. And then she stayed there for 1 more second. And done. Got the picture? All right. What was the average rate of change for the swimmer going up the ladder? Okay, so let's look at the points. She started at 0, 0, and going up at 2, she was at 5. Do we agree? So the change in the y, she went from, changing y was, if we do the math, 5 minus 0, change in the y, over the change in the x. And that would be 2 minus 0, which is just simply 5 over 2, which if we divide 5 over 2, don't we get 2.5 feet per 1 second? So that's her rate. 2.5 feet per 1 second. So in 2 seconds, that's how she got to 5. Change in y over change in x. The change in the y went up to 5, and the change in the x was only 2. Okay, this is the run is 2, the rise is 5 units. You can see it in the picture. At what interval of time is the slope negative? What interval of time? Interval means a segment, a part. How are we going to identify that interval of time? So when was the line going downhill? Was between the 4th second and the 6th second. So from 4 to the 6 seconds was a negative. And the slope of 0, where was she at the slope of 0? There are actually 3 different intervals. The first was between 2 seconds and what? Between 2 seconds and 4 seconds. She was 0. The second 0 slope was down here between the 6 seconds and 8 seconds. And the last one, the third one, the third one, okay, was the very last second, from 9 seconds to the 10th second. And that's where her slope was 0. Okay, this is a sample of a Part 2 question on the state test. You might be given the picture, you might be given the story, you might be given one or the other, and you have to kind of interpret what is going on based on the math in the story. Okay? All right, so the next problems are homework problems. Determine the slope. Find how the change, okay, well, I'll give you the formula here. The change change in y over the change in x. That's your m. Find your slope, okay? Slope is m. There's your m, all right? Then it says plot the points on this graph. So you're going to take these coordinates. Remember how to read this. This is, the coordinate here is -2, 4. Oh, I'm sorry. Sorry. I wrote it backwards. See, I make mistakes. The points here are, 4, -2. The next point is 5, 0. The next point is 6, 2. And the next point is 7, 4. You will graph them on here using a straight edge or ruler. Make a nice line. And now you will be able to work out, see the slope from the table, and you'll be able to see the slope from this graph, okay? If their line did not copy, just gently put it in there so you see it, all right? Sometimes the graphics do not always copy out perfectly, all right? Same with the bottom. Use the formula. If you can determine here the slope, the change in y, remember, change in y over change in x. Work these out, both of these, all right? And then the next 2 pages are also continuations of the same type of problems. Take a look and see if you can determine the slope. State whether the slope is positive, negative, 0, or undefined. Calculate the slope so you can determine. Okay? And then these are using the formula. This would be m equals y2 minus y1 over x2 minus x1.